So now that we got that crystalline pseudoephedrine hydrochloride or ephedrine hydrochloride, how do you go about turning it into crank? Well, you know, I'm sort of getting disappointed with this place. It doesn't work very well with pseudoephedrine. And it's just too hard for the typical person out there to do. So, to convert the pseudoephed or ephedrine into crank, you're left with a couple of good alternatives. One is the liquid ammonia and lithium battery method. That's a good method, but it makes a hell of a stink because the liquid ammonia just evaporates off, you know, as it's going. And, well, you can't do it in any populated area. Another good alternative is the old HI red P reduction. That's the one we're going to demonstrate. Simple ingredients, iodine tincture from the farmer's store. Get the strongest stuff you can find. A little bit of hydrogen peroxide. And this here is hydrochloric acid. It's the concentrated variety, diluted half and half with water. So it's like about 15 to maybe 20% HCl, something like that. You can get that at the hardware store too. All right. So, to demonstrate how this is done, I use a magnetic stir here because it makes things easier, but it's not really necessary. Let's demonstrate with, let's say 100 mLs at a time of this 7% tincture. It says here on the label, 7% iodine and 3% potassium iodide, which makes it like about 9% total iodine, you know. So, let's go with about 100 mLs. Into the glass container. And we add a few volumes of water. To dilute things down. And I take this hydrochloric acid here, it's diluted 1-to-1 with water, and I add roughly half as much hydrochloric acid as I used iodine. Pour that in. And we come to the good part. A little bit of peroxide. The peroxide here will oxidize the Ki, or potassium iodide, to iodine, and will also help to get the material out of solution form, make crystalline iodine. How much of this do we use? Well, you use enough that you've got roughly 2 or 3 volumes of peroxide for every 1 volume of the iodine tincture. Pour it in a bit at a time. And allow it to react with stirring. And allow the stirring to continue. So after about 5 minutes of stirring, we pull out another portion of hydrogen peroxide solution. This is the 3%, that stuff that you get down at the drugstore, grocery store. Add it to the tincture. I like to add it about half at a time there. So the reason why you want to make your own iodine from tincture is because it's difficult to buy pure iodine crystals. Pure iodine crystals are far preferable to the tincture variety, but they're, like I say, they're very difficult to get and not worth the hassle and the danger. People know what they're good for. You might notice a little cloud of iodine vapor coming up above the solution in there. It's kind of turning purple in there, you know, the vapor. It's a good idea to do this with sufficient ventilation because you don't want to be breathing these fumes. They're toxic and bad for you. Add a little bit more. And let that stir in for a couple minutes. For a third portion of hydrogen peroxide. You'll note here, I'm not sure if the lighting is quite good enough, but we'll show that a large proportion of the iodine that was in the solution here is now along the bottom here. They're heavy, you know, along the bottom of the flask. And the liquid here is getting quite a bit lighter and more transparent. So most of the iodine has already come out of solution. We'll let it react here for a little while yet before we proceed. About 15 minutes now, it's reacted and settled out. I have a reddish colored liquid and a bunch of black solid on the bottom. Black solid are iodine crystals. I want to keep them. The reddish color in the water is some iodine that's still dissolved and floating around in there. And I don't want to throw that away. I want to recover it. I want to get all of it. So in order to do that, what I'll do, I'll use a step funnel. Pour the liquid in here. I'll use some toluene. This is some awfully useful stuff, let me tell you. And I'll extract out the iodine that's floating around in the liquid with the toluene. I could add a bit more, I think. So this is a total of roughly 100 mLs of toluene, I'd say. Into the step funnel it goes, and we shake. Now you can rig up your own step funnel from simple materials that are easy to find. You can read about in Jack B. Nimble's book, Construction and Operation of Clandestine Drug Laboratories. But let it sit. Toluene will come floating up to the top. And it'll have the iodine in it. Just give it some time to work its way up. Generally takes about 2 minutes. After waiting a few minutes, the toluene is largely separated out from the water. So we get rid of the water. We don't want that. It can go in the trash. Down the toilet. And away it goes. And we're getting close to the bottom. Time to slow this up a little bit. Alright. And right when it gets to the bottom, that's when we shut it off. So this consists of an iodine in toluene solution. We want to save that. Best way to save it, it's an old Grolsch bottle, beer bottle with a resealable lid. Pour it in there. And we go after the rest. If you have a step funnel big enough to hold all of it at one time, well, that'd make your life a little bit simpler. All right, here is my mass of iodine crystals. I want to rinse them a little bit with water. And they do cause the eyes to water as well. Good ventilation. So rinse them a little bit. Allow them to settle. Now then, we extract this portion here with toluene also. And shake to extract it. Let it sit to allow the layers of water and toluene to separate. Water and the iodine layer contained in toluene. Well, we just drain off the water, just like before. And it's getting close to the bottom again, so it's time to slow it down. And when it gets right down to the bottom, turn off the valve. And into the beer bottle, this also goes, along with the first load. All right. Then you seal up that beer bottle and into the refrigerator with it. Now we're going to go after our crystals of iodine that have fallen out of solution. Inside the flask there. Good ventilation. I must caution once again. So to get them out, what am I going to do? I'm going to filter them through doubled up coffee filters there in this little filtering funnel. And away we go. You'll note some sticks to the inside of the flask. There's two ways you can deal with this. Get some more water, chase it out. Option number 2, you just let the flask sort of dry out a little bit and then scrape it out with a fork or a knife. It's up to you. Either one works. You took water, you swoosh it around in there, get them suspended, pour them through the filter with the rest. So, here we go with our product. Squeeze the water out of it. Then, onto wax paper with it to air dry. in an area that has decent ventilation. All right. Air dry those buggers. Iodine crystals. You know they wear gloves there, you know, so you don't stain your skin. And it's starting to cause my eyes to tear just a little bit also. These fumes are not good for you. I must caution once again. So, onto the wax paper, a little bit of air drying. What you do with them is you put them inside a glass jar with a plastic-lined sealable lid, such as like a baby food jar or some other small food jar there with a good seal on the lid that's also plastic-lined.
The ingredient one has to get cut. Red pea. Now, as you have it, that's a very, very difficult ingredient to obtain by normal commerce channels. So one has to use subterfuge in order to obtain it, or determination. The most readily available source of red pea is a striking pad of matchbooks. If you get a whole lot of matchbooks together, you scrape off that red striking pad there and collect the scrapings and purify it by the directions given in Secrets of Methamphetamine Manufacture, you'll get a reasonably pure red phosphorus that you can use in making meth, along with the iodine. Iodine red pea reduction method of pseudoephedrine or ephedrine. That's a lot of work. There is an alternative that's a lot less work and more easily scaled up. That's the method using sodium hypophosphite. We can make hyphosphorus acid from sodium hypophosphite, this material right here, and phosphorus acid. Hypophosphorus acid will react in the same way as red pea does towards iodine and be equally as useful in our reaction. Now, hypophosphorus acid is a very tightly controlled chemical these days because it is very useful just like red pea is. So in order to get hypophosphorus acid, one has to make it, but it's very easy to do. Starting with sodium hypophosphite. I have 20 grams of it right here. Making hypophosphorus acid is very easy. First you put it in a convenient sized glass container. There she goes. 20 grams of sodium hypophosphite will give you roughly 12 grams or so of hypophosphorus acid. The acid is a liquid. This is hydrochloric acid, diluted 1-to-1 with water. I'll add the smallest amount that I can get it to dissolve in. Yeah, let's go with roughly. Fill it up to 50 grams or so. Now this will take a while for it to dissolve. Use a glass rod, stir it, it'll dissolve. Salt, so the reaction is sodium hypophosphite reacts with hydrochloric acid to make hypophosphorus acid plus table salt. Yeah, that's mostly table salt settled out at the bottom of the reaction mixture there. This hypophosphorus acid there, since it's so useful, you might wonder, where do you get the sodium hypophosphite? Well, you don't want to deal with these guys. Grab a copy of the Metal Finishing Guidebook. There are all sorts of suppliers for what a process is called electroless nickel plating. Electroless nickel plating uses sodium hypophosphite in water solution along with nickel in order to produce a nickel plate upon metal objects or plastic. You go through the supplier listings in here and you'll find all sorts of them. Another place you could find listings of suppliers would be to go to the internet and do a search under electroless nickel suppliers. And you'll find people selling sodium hypophosphite in large quantities, cheap prices, and salesmen want to sell, of course, you know, so it's not that hard to get a pound or 2 or 3 or 4 or 5, maybe 10 or 100. how do we go about dealing with this now? Hypophosphorus acid in the water solution. Well, you can extract out with ether. I get a can of starting fluid down at the hardware store, chilled it down in the refrigerator, took this glass flask here, packed it in ice, went out in the garage and sprayed it full of the ether starting fluid. It's good enough ether to use for this purpose here. So, to get our product, we extract it out. Leave that stuff in there. A bit of ether. Take about half of it. Stopper and shake. Now ether always builds up pressure when you shake it with water. So you gotta periodically vent it. Yeah, one more good shake. All right. Now, see the ether layer is floating on top. The ether extracts hypophosphorus acid. Drain off the water. Back in with a salt kook. And it's kind of hard to see exactly where the water ends and ether begins, but it's right about there. All right, this we want to keep. Put it into a filtering flask, like so. Stopper it. And of course, ether smells like hell, which is why you want to keep the amounts used down to a minimum. Why you want to do the spraying of the starting fluid out in the garage. And what we're going to do here is see if we have any left. Since most of the hypophosphorus acid has been extracted into the water, out of the water into the ether, if there's any sodium hypophosphite left down that salt, it should now come up into the water, and we can get it with the next extraction. So we'll let it settle here for about 10 minutes. Time to get whatever is left in there. So, once again, we pour off the water off that salt that's settled out. The water contains within it the hypophosphorus acid that we want. We're going to extract whatever we didn't get the first time around. We're using a fresh portion of ether. Shake again, like the first time. And again. And finally one more time. And we let the two layers separate. Water goes on the bottom. Ether floats up to the top. And they've separated nicely already. So, drain off the water. And we put the ether layer in with the ether that we got from the first run. Now then, this can go down the drain, earliest convenient moment. What we do with the ether then, stop at the top of this filtering flask, you attach a vacuum line to here. A water pump aspirator would be the best source of vacuum because then the water flow will suck the ether fumes down the drain and you won't be stinking everybody out because ether is very, very recognizable by its smell and it carries a long ways. Then, once you apply a vacuum to it, the ether will evaporate away, may even boil. You shake it around a little bit. And it'll evaporate down until you're left with an oily liquid at the bottom that no longer evaporates and boils away, and that's your hypophosphorus acid. It'll be clear and rather thick. Now I'll show you a related way to get the hypophosphorus acid from a plating chemical that's more likely to be easily available to you. Is to a more easily available, to use a more easily available samples. I got this sample. Salesmen come around all the time. I'm sure that many people would not have much problem at all talking salesmen of electroless nickel products out of samples of their products, because that's what they do. They give away samples, and then they try to make a sale. Generally, you get the sample for free. This is a quart jug here. This particular ingredient here, it's manufactured by Heat Bath. There's like so many manufacturers of electroless nickel products there that I couldn't even begin to name them. The electroless nickel product that you particularly want would be the hypophosphite replenisher component for the electroless nickel bath. It might be called the R component. It might be called the C component. It is R for replenisher there, the hypophosphite, or C for like the number 3 component. It's what is added to an electroless nickel bath as it is worked there in order to keep the hypophosphite concentration up into workable range. This particular product is particularly concentrated. It's roughly 500 grams of sodium hypophosphite per liter. Others would be a little bit less concentrated. It might be ranging from about 350 grams per liter up to 500 is about as strong as I've found. This one is a very, very concentrated solution. Now, in order to get hypophosphorus acid from this water solution of sodium hypophosphite, which is basically all it is, it's got a couple minor other ingredients in there, but we can ignore them. 50 grams of sodium hypophosphite. To get 25 grams of sodium hypophosphite, you then use 50 mLs of this solution. 50 mLs there. Since there's already water in this mix, and you don't want it to overly dilute in order to defeat the ether extraction, because the hypophosphorus acid does dissolve in the water, you want to then use concentrated hydrochloric acid. Don't use any other acid, sulfuric, no. Hydrochloric acid. The muriatic acid that you get at the hardware store would be good enough if you use it straight. Now then, we add this here, little bits at a time. Stir it in. And allow it to react we've had a few minutes here for it to react. You can tell that this solution here is more diluted than the one that we used with powdered sodium hypophosphite, because no salt settled out at the bottom when the hydrochloric acid was mixed with the sodium hypophosphite. There was enough water in the mixture there to keep the salt dissolved. Now to recover the hypophosphorus acid, we do it exactly the same way as with the powdered sodium hypophosphite. Pour the acidified hypophosphite solution into the sep funnel, our ether. Store it in the freezer there. It won't evaporate away on you. And stopper that. And we extract it. Then we let the layers separate. Drain back the water layer into the original beaker. And right where the ether meets the water, I've got a little layer of like foamy bubbles. I'll let them drain down into the water. Okay, so this ether solution, we want to save it. It's got the hyphosphorus acid that we need. Then to get a decent recovery of product from the water solution, extract it again. A little bit of ether. Now we wait for the layers to separate. See, among other ingredients in electrolysis nickel solution is detergent. And they're breaking up. And any foamy bubbles or splooginess we got at the bottom, we will let go into the water. So, this extraction 2, we place in with the ether extraction from the first run. And as was shown in the first example there with the sodium hypophosphite, what you want to do is attach a vacuum line here. Attach that to a water pump aspirator, preferably, and under a vacuum, evaporate away all the ether, and that'll leave you between like 12 or 15 grams of sodium hypophosphite, of hypophosphorus acid oil sitting at the bottom.
So, now that we've got stuff made, we're ready to cook a batch of crank. Now, there's 2 alternate ways, actually there's 4 alternate ways that we can do this here, depending on whether one has gone through the bother of scraping off the red phosphorus from matchbook striking pads, or if you've produced hypophosphorus acid. Now, hypophosphorus acid, here, this is a product I got from that electrolysis nickel product after I evaporated off all the ether underneath the vacuum. Once you get it this concentrated, you have to keep it stored in the freezer there until it's ready for use, because it will not keep at room temperature. So I just got it out of the freezer. We have 2 ways to go about this. Using the hypophosphorus acid, these are the proportions. Using red phosphorus, these are the proportions over here for a 10-gram batch. Now there are 2 alternate routes to actually do this HI and red P or hypophosphorus reduction. A very popular method is the push-pull method. You do it directly in a little flask just like this. Stopper the top, run a line off the side to a couple of milk jugs filled with water, the line going down the bottom. The idea of that is to pressurize the inside of this container just a little bit, or you can just take a tough rubber bulb here and put it on the end here so you'd like blow up a balloon, you know, with a little bit of pressure, not a lot of pressure, but a little bit. The bad thing about that particular method is if you're using hypophosphorus acid, it's very possible to get a fire going. And you'd have to have a slopping wet towel ready to just throw it on top of the little fire there in order to quench it out. Well, I think it'd be a little bit embarrassing here if on film here I have to start fighting a fire. I can see that one turning up on TV. So, the method we're going to demonstrate here is just the plain old standard cook option, where you boil the solution. See, for the push-pull, you would use the pure concentrated hypophosphorus acid. For the cook version, you dilute the hypophosphorus acid down with a little bit of water and you boil. So, anyway, we're about ready to proceed here. This is that iodine extract there from the iodine tincture. Remember, I kept some of that in a Grolsch beer bottle. These are iodine granules that I got after they dried out when I precipitated them out of the iodine tincture. Now, the amount that you're going to get in solid form versus in the solution form will vary with how strong your iodine tincture is. I used the 7%, and that gave me roughly 90% of the iodine in this rock form, which is much simpler and easier to weigh out, and the other 10% in the solution. Now, if you use weaker tinctures, like say if you get down to like 2% iodine tincture, the majority is going to be recovered in your toluene extract, and you'll just get a little bit of actual solid iodine. You go down to 1% iodine tincture, which is really a joke, all of the iodine you're going to recover will be in the extract. So to begin here, we start. Let's measure out our 12 mLs of hypophosphorus acid. Notice it's kind of thick. That's about 12 mLs. In she goes. Now, I'll dilute this hypophosphorus acid here with 25 mLs of water. There we go. And another portion. And we can commence. It'll clear up once it's all dissolved in. This toluene extract here. How would you get the two of them to react? Well, it's not very difficult at all. Let's get something on the eyeballs here to protect things. But they react together just fine. Let's take some out. Little iodine extract there and toluene. Now to get them to react, you have to stir them. And that's with 1 minute of stirring in. See how much lighter it is already? It's reacting along nicely. Give it 1. And now with 2 minutes of stirring in, all of the iodine is reacted. So we'll turn off the stir and let it separate. So on top floats the toluene that used to contain the iodine. And on the bottom is a solution of hydroiodic acid. course, there's nowhere near enough in there to do the reaction yet, but I was just showing you how to use the toluene extract. We don't have to use a lot of toluene extract in order to get the required 25 grams into there. That was just a start. That was just to show you how to do it using that extract with toluene. Now we'll move on to using the little chunks of iodine there that I accumulated from the tincture. And you just add them to it. Slowly, a bit at a time, they react. Now if this is red phosphorus, it will react much more violently. And it get very, very hot. But hypophosphorus acid reacts a little bit more slowly with iodine, and not quite so forcefully. And you don't really need to stir it and eventually react on its own, but stirring speeds things along. That took about 10 minutes for the iodine to react with the hypophosphorus acid and get into a solution, make HI with a fair amount of leftover hypophosphorus acid still in the solution there to act like a red P. Need that extra hypophosphorus acid in order to make the reaction go, because the solution will continually break down and produce iodine. That's why it's got a slight tint of yellow to it. It'll continually break down to make iodine. You need that hypophosphorus acid there to recycle it back to HI. So, it didn't even get particularly warm. It got warm, but not hot. If this was red P I was using instead of hypophosphorus acid, this would have become boiling hot, and you'd have to have done the reaction in this little round bottom flask, which we're going to use right here as our reaction flask to make the crank. So in she goes. Ooh, and there goes my stir bar. Yeah. 10 grams ephedrine hydrochloride. You can use pseudoephedrine hydrochloride just as well. Ephedrine is a little bit preferable, and I've always liked it. And you'll note there's no real obvious reaction as they mix, as the ephedrine goes into the acid there. It doesn't dissolve completely either until it gets hot. So now we're ready to cook. So anyway, this is the cooking apparatus. I have a condenser attached to the top of that round bottom flask. And from the sink, we have inlet water coming in at the bottom, cold water to flow through the condenser, and out the top of the condenser, the water exits in order to keep the condenser cooled. And it's about time to start cooking this. You can see on the bottom the ephedrine hydrochloride still is not dissolved completely, but it will as soon as I start to heat it, to keep the fumes inside as it boils. We have boiling just beginning. Oops. In the solution will be in a little bit here. And you'll let it boil like this for roughly 12 hours at roughly that pace. Now I know what you're going to say. I don't have that round bottom flask or condenser. I can't get chemical glassware that's sophisticated like that. Not down to local stores anyway. And I don't want to make myself a target by doing suspicious things. That's good thinking. You can get flasks like this at the local hobby shop. Notice a nice long neck on it. The longer neck, the better. You want to get a flask that's made out of Pyrex or Chimax. Now you could do exactly the same boil I have going with that ephedrine right there in a flask like this. If you take some copper tubing and you just wrap it around the outside, starting at, right about at that point right there, you know, and you'd have the solution boiling way down here, you know. Start wrapping it with copper tubing. Don't bother with plastic tubing. It doesn't transfer heat well enough. Copper tubing. Wrap it around and around and around and around to get to the top, and then, well, you hook a water line at the top there and discharge the cold water. This will cool down the outside of the flask up here and will act like a condenser for you, as long as you don't boil too fast on it. You don't need that big fast boil. Mixture for at least 12 hours here. You notice it's developed a bit of a golden color to it. Now, if I was using red phosphorus, the mixture would still look very red and messy looking, and what I'd have to do is filter the mixture through doubled up coffee filters to filter out the red phosphorus, and then you get a golden colored mixture like that. Now that I've got it this far, it's time for me to collect my product. Now to do that, I have to neutralize all the HI, all the acid inside this mixture here with red double lye. Already mixed up in solution. This is about 20% by weight. Red double lye in water. I've allowed that to cool down because when they react, things can get a little bit exciting. So I take my product over here